Hello everybody and welcome to today's lesson on permutations and combinations. Today our objective is we will compute and distinguish between permutations and combinations and use technology for applications. In order to get started, let's talk about a principle that is very important for all areas of probability and statistics, the fundamental counting principle. And the fundamental counting principle says if one event can occur m ways and another event can occur in n ways, then the number of ways that both can occur is m times n. So we multiply the number of ways that the one event can occur with the number of events that the other event can occur. Let's try this out on the example of a Virginia license plate. The standard configuration for a Virginia license plate is 3 letters followed by 4 numbers. Here we have an example, which by the way, that is not my number plate. How many possible license plates are available in this configuration? With first 3 letters and then 4 numbers. For the first letter, we have 26 different possibilities, right? And then the same is true for the second letter and for the third letter. And then we start with our numbers. We have numbers from 0 to 9, so that means 10 different numbers. And we have 10 different possibilities for the next number, and for the third, and for the last. These are all the different possibilities we have for each one of the places of this number plate. And if we want to know how many that is in total, following the fundamental counting principle, we just multiply each of these possibilities together with each other. And as we do that and put it into your calculator, we get a huge number. In fact, we get 175,760,000 different possibilities. That's quite a lot. So that's going to be enough for everybody in Virginia for a while to go. Now let's see how many possible plates are available if the letters cannot be repeated. A letter that's used once cannot be used again. Well, for the first letter, we still have 26 possibilities, right? But then if one is taken, the second letter, we only have 25 possibilities. For the third, we have 24 possibilities because there are already 2 letters taken. Now, the numbers can repeat, so we still have 10 possibilities for the first number, the second, the third, and the fourth. How many is that going to be? We'll multiply them all together again. It's probably still a pretty huge number, although it's less than before, I'm guessing. And as you punch this into your calculator, you will see it's 156 million possibilities. Now let's see how many possible plates are available if both the letters and the numbers cannot be repeated. So for the letters, that would be just like in the example before, 26 possibilities for the first, 25 for the second, 24 for the third letter. Now our first number still has 10 possibilities, but our second only has 9. One number is already taken. The third only has 8 possibilities because 2 are already taken. And the fourth only has 7 possibilities because 3 have been taken. Now let's multiply this together. And we get 78,624,000. Now that's still a pretty huge number, but it's less than half of what we had in our first example. That's the difference it makes if we can only use each number and each letter once. Now these different possibilities that we can combine these letters and numbers in the number plate are called permutations. The order in which we arrange objects is called a permutation. So the different ways we can change that order are all different permutations of the same group of elements. Like for example with these three letters A, B, C, they can be arranged in the following ways. Of course, we can arrange them in the right order. A, B, C. We can change around the C and the B. A, C, B. Now we can put B first. B, A, C or B, C, A. And we can also start with the C. C, A, B. C, B, A. Those are the different possibilities. So we have 6 different ways that we can arrange the order of those 3 letters. And why did we have 6 different ways to do this? We could start with our first position. We had 3 different letters that we could put in the first position. So we had 3 possibilities for that first position. Then after 1 letter is already taken, we have still 2 possibilities for the next position. And after 2 letters are taken, we really only have 1 more letter left that can go in the last place. So we have 3 times 2 times 1, which is 6 possibilities. And mathematicians have invented a special type of notation for this type of thing because they use it a lot in probability, and it's called n factorial. It's written with n and an exclamation point, and it's pronounced n factorial. So plug in any number for n and you can calculate it. So what we had down here in our example with ABC, we have 3 factorial, and that is 3 times 2 times 1. If we had 5 factorial, for example, that would be 5 times 4 times 3 times 2 times 1. And the way we can calculate this easier than doing it in our heads is using our calculator that has a special function for that. So if we wanted to know what 5 factorial is, take the number 5 and now go into the math menu, go over 3 steps to probability, and number 4 is factorial, and 5 factorial is 120. Those numbers tend to get large very fast as you're multiplying ever larger and larger numbers with each other. Now let's look at another example. How could the letters A, C, C be arranged? In how many different ways? Oh, we can do A, C, C. Then we can start with a C, and we could do C, A, C, or we could do C, C, A. Anything else left? I don't think so. So here we really only have 3 ways. Well, that's odd. We had 3 letters just like in the example above with A, B, C. Why are there fewer possibilities this time to combine these 3 letters? I'm sure you have figured out the answer, which is because some of the letters repeat. Right? If some of the letters repeat, that means that it doesn't matter which of them we put in a specific place because they are the same. And that leads us to our next discovery. If a permutation of m objects has an object that repeats s times, then the number of permutations that we can get is found by the following formula: m factorial over s factorial. And let's try this out right away with a couple more examples. How many different ways can we rearrange the letters in the name of the state of Alaska, considering that we have some letters that repeat? So we have 6 different objects, 6 different letters that we could rearrange. That would be 6 factorial. But since the A is in here a few times, actually 3 times, we have to divide this by 3 factorial according to the formula that we just learned. So how many possibilities would that give us? We would have 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1. That means we can cancel these guys out, and we have then 6 times 5 times 4. 6 times 5 is 30, times 4 is 120 possibilities. 120 permutations. Let's try this out right away with another example. Let's use the word mathematical. And how many letters does the word mathematical have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we got 12 factorial, but how many possibilities will not be different? Can we eliminate? So we have A in here 3 times. We have the M in there twice. And we have a T in there twice as well. So in our formula we can say 12 factorial divided by 3 factorial divided by 2 factorial divided by 2 factorial. Now this one we don't want to do in our heads. We're going to use our handy dandy calculator. Alpha y equals 2 and 1 will let us set up a nice fraction. And now I've set it up already nicely. Remember to get to your factorial, it's math, prob, and number 4. And enter. And we get a pretty large number again. 19,958,400. Even though we had a few letters that repeated, we still have a huge number of permutations of the letters in the word mathematical. Alright then, so much for this, and now go ahead and watch the second part of this tutorial.